Hello everyone. Hope you all are doing well. Today we will start the new subject, that is soil science. And the soil science is very a major subject when we consider from the specific paper point of view, because around 8 to 10 questions will be from the soil science, and each question carries 3 marks. That means 24 to 30 marks will be from the soil science. That's why it is important. Okay. So we will study some of the important concept, some of the important topics from the soil science, because in order to cover each and every topic that is mentioned in the syllabus, it is very difficult. So we will cover some of the important topics, and those topics were repeatedly asked in the previous year questions, previous year exams, whether it is any kind of agricultural exams. So we will study some of the important concepts from the soil science. The So let us start. When we think of soil science, these two terms we have to remember. These two are Greek terms, that is pedology and edaphology. The pedology is, when you divide this pedology word, it is consist of pedon and logos. Pedon is soil. Pedon is soil, and the logos is study. So it's a study of soil. The pedology is a study of soil. One more word is edaphology. Let me erase this one. One more word is edaphology. It is also a Greek term. Edaphology is nothing but the study of soil from the standpoint of higher plants. Study of soil from the standpoint of higher plant. It means how soil is interacting or helping, how soil is helping the higher plants for their growth. So it's a study of soil from the standpoint of the higher plant. These two terms are very important, and we have to remember this. So let us move to the next topic, that is some of the important institutions which are related to soil science. See, if you take the previous year questions, one or two questions will be from the some of the institutes. Some of the institute, which it can be from the soil science, or it can be agriculture or entomology. Any ICR institute will be asked. Either they ask the full form, or they'll ask this location of the institute. So we have better we will remember some of the important institutes. So let us the first institute is IISC. It's not SC, it's a SS. IISS, that is Indian Institute of Soil Science, which is located at Bhopal. Let me tell you the one trick, that is Bhopal. Think it is as a bhumi. Bhumi means soil. So Indian Institute of Soil Science is located at Bhopal. That's what we have to remember. It's one of the trick you can remember. So the second institute is NPSSLUP, that is National Bureau of Soil Survey and Land Use Planning. I think you might have heard about this institute many number of times, and which is located at Nagpur, which is in Maharashtra. So the second institute, NPSSLUP, that is located at Nagpur. The third institute is Central Soil and Water Conservation Institute. Central Soil and Water Conservation Research Institute, which is located at Dehradun, which is at Uttarakhand. When it comes to conservation, you remember that it is in Dehradun. Then the fourth institute is National Institute of Organic Farming. When it comes to organic farming, you remember the Ghaziabad, which is in UP. Okay. What are the four institutes? One is IISS, Indian Institute of Soil Science, which is located at Bhopal. And the second is NPSSLUP, that is National Bureau of Soil Survey and Land Use Planning, that is at Nagpur. And the third one is CSWCRI, which is located at Dehradun. And the fourth one is National Institute of Organic Farming, which is located at Ghaziabad, which is in UP. So let us move to the next topic, that is the composition of earth crust. We all know The crust is outermost part. Crust is outermost part of earth. That's what the crust is. It's a solid mass. And the crust can be from the continental, in the continent, or as well as in the oceanic. Crust in the continental as well as the oceanic crust. So the earth crust is composed mainly of many number of minerals. So if we divide those minerals, those components from the earth crust, we can divide them in the non-metallic and the metallic minerals. When we think of non-metallic, it is an oxygen and silica. And the silicon consists of around 27.8% of earth crust. 27.8% of earth is composed of silicon, and the oxygen is 46.6%. When we see the in the air oxygen in the air is about 20.9%. When we think of earth crust, it is 46%. You remember this, make the difference. And the second component is metallic component. It can be aluminium, it can be iron, it can be calcium, it can be magnesium, or any mineral. So whatever the left out, around 30%, around approximately 25 to 30% of mineral is a metallic mineral in the earth crust. And now we will see the composition of the soil. The soil is different and the earth crust is different. Crust is outermost or solid part of the earth, and the soil is not the entire crust. Soil is outermost part of the crust. Soil is outermost part of the earth. Outermost part of crust. So if we consider the composition of the soil composed of many number of components. It can be a mineral matter, it can be organic matter, it consists of soil, water, it consists of air, water, and many. So when we consider it mineral, it is of 45%. When we consider the organic matter, it is of 5%, and the soil and air consist of 25% each. So you better remember this chronology. Mineral matter consists of 45%, soil water consists of 25%, soil air consists of 25%, and the organic matter consists of 5%. You remember this chronology. It can be asked for the example. And when we consider some of the important components of the atmosphere, these are some of the important components. Nitrogen, oxygen, and carbon dioxide, these are the basic for life. So and these component varies in soil as well as air. Let us remember, let us see what are the percentage of this nitrogen, oxygen, carbon dioxide in air and the soil. So in nitrogen, air consists of around 78.8% of nitrogen. 78.8% of nitrogen that is present in air. In soil, there is a slightly difference. There is a slight increase of nitrogen content in the soil, and it is more than this. In soil, nitrogen is more than compared to air, because the nitrogen helps in growth of microorganisms, growth of plants and all. So in soil, the nitrogen percent is more than the air. When it comes to oxygen, in the air, oxygen is more than the soil. It's a slight difference. In air, oxygen content is more than the soil. When it comes to carbon dioxide, in soil it is more than the air. It's in soil it is 0.3%, and in air it is 0.033%. So you remember this. Now let us move to the next topic, that is minerals. What are minerals? Minerals which is present in the earth, they have some definite chemical composition. They have, not everything is mineral. Mineral is one, that is that thing that have some definite chemical composition and have some crystal structure. They have some composition which should be definite, and they have some structure. These two components should, should be there. Sorry, not the components, and these two character, the mineral should satisfy these two characters. The mineral should have some definite chemical composition and the mineral should have some crystal structure. These two components should satisfy for the minerals. There are different kinds of minerals, right? There are some primary minerals and the secondary minerals. The primary minerals are, they crystallizes. Primary mineral, they crystallize or they solidifies directly from the magma. Directly from magma. So these are the primary minerals. When the magma comes from the earth, from the earth, when it reaches the earth, it solidifies, it cools down. Those are the primary minerals. Example is feldspar, mica, and the quartz. They are the original constituents of the rocks. Whereas the secondary minerals, they are formed from the primary minerals. These formed from the primary minerals, from the changes in the primary minerals. And the example for the secondary minerals is illite, kaolinite, gypsum. And these secondary minerals are also known as clay minerals. So in case of primary minerals, the example are igneous rocks. Example of primary minerals, igneous rocks. Where in case of secondary minerals is sedimentary rocks. You remember this one, sedimentary rocks. Sedimentary rocks are example of secondary minerals because we will discuss about the different kinds of rocks in the further classes in the further this one PDF. So the secondary minerals are also known as clay minerals. When we see this clay, we have to remember the size of the clay, because we know there are different sizes in the soil. Based on the sizes, we divide the soil. So when it comes to clay, the size should be less than 0.002. That's what the clay mineral is. So see, now let's see the soil particle sizes and the characteristics. Based on the size, we divide the soil particles. When it comes to clay, the diameter of the soil particle should be less than 0.002. And in the clay there are a lot, it consists of lots of pores, especially micropores, and the permeability is very low because of high number of micropores and the less macropores. So permeability is low but the porosity is highest. In case of silt, the size is between 0.002 to 0.05, and the porosity is low here, and because of porosity is low, the permeability is also low. The third one is sand. The soil particles, having the size from 0.5 to 2 mm. In sand there is a high porosity, large number of macropores. So the permeability is very high in case of sand. In case of gravel, the size is more than 2 mm. The porosity is very low. See, the gravel having irregular shapes, so the porosity is low. There is no micro or macropore. There is voids. Those are gaps, and the permeability is very high in case of gravel. So you better remember this sizes, and the porosity also. When you consume this, remember this porosity, the permeability will definitely follow. So we'll see some of the important nutrients in the soil, and these nutrients are very important with respect to exam, because these are the some of the minerals, these are some of the nutrients come from some definite sources, right? In case of nitrogen, it comes from the organic matter. So magnesium comes from dolomite. Magnesium mineral comes from the dolomite. So the source of magnesium is dolomite. And the next one is boron. The source of boron is tourmaline and the borax. The source of sulfur is gypsum, pyrite, organic matter. The source of iron is hematite, magnetite. You might be knowing this. The source of manganese is magnetite. The source of silica is quartz. The source of phosphorus is apatite. So you remember some of the important, and these are selected important minerals that I have taken. So you remember this NPK and this aluminium. The source of nitrogen is organic matter. The source of phosphorus is apatite. And this question have been asked previously. And the source of potassium is sylvite, micas, and feldspar and biotite. The source of molybdenum is olivine, the molybdenite. The source of aluminum is bauxite. And this question is also asked in the GK paper by the KPSC. In GK paper, they have asked what is the ore of this bauxite. So you remember this. You study multiple times so that you will remember easily. The next is clay minerals. Clay minerals are secondary minerals. These are the secondary minerals. Clay minerals ಅಲ್ಲಿ there are further two types. One is expanding clay minerals and the non-expanding clay minerals. ಇದು word ನೋಡಿದ್ರೇನೆ we can assume it expands. In the word itself, there is a word expand. So when water enters into these minerals, there will be different kinds of different layers of minerals will be there. So once the water enters into these gaps, it expands. It expands, right? The mineral gets expand. So that's why it is expanding. And you remember these examples. These examples are very important. Mount Morlinite and vermiculite are the two examples for the expanding type of minerals. See, the definition is minerals swell when wet. Minerals expand when wet as water enters into interlayer space between the layers of these minerals. So, it is 2 is to 1. What is 2 is to 1? There will be two layers of silicon tetrahedral. Silica tetrahedral. There will be two layers, and there will be one middle layer of aluminium octahedral. So that's why it is 2. These 2 is to 1. That's why it is 2 is to 1. When water enters into these gaps, it expands. So it is 2 is to 1. Examples are Mont Morlinite and vermiculite. Further, the Mont Morlinite is fully expanding and vermiculite is partially expanding. When we come to the non-expanding type, by word itself we can assume that it is not expanding. When water even gets into this interlayer space, it do not get expand. So the examples are kaolinite, illite, and the chlorite. You remember these examples, and these are very important for the example. Kaolinite, illite, and chlorite. Illite is 2 is to 1, kaolinite is 1 is to 1, and the chlorite is 2 is to 1 is to 1. And when we think that the weathering of minerals, when we think of weathering of minerals, not every mineral, not every rocks is equally weathered, right? Some minerals are very resistant to weathering process. Some are the very susceptible to weathering. So when you think of quartz, it is more resistant to weathering. When it comes to feldspar, it is moderately resistant. When it comes to calcite, it is least resistant. So you remember this chronology that quartz is resistant to weathering, feldspar is moderately resistant, calcite is least resistant. It is very susceptible to weathering. I hope you understood this topic. Let us move on to the next topic. The next topic is the classification of minerals based on the silica content. We know the earth crust is made up of many number of minerals. When we divide these minerals, there are two kinds of minerals. There is silicate minerals and the non-silicate minerals. Silicate minerals and the non-silicate minerals. Minerals are main component of earth crust. Around 90% of earth crust is composed of silicate minerals. In case of non-silicate minerals, it consists of only 8 to 10% of earth crust. Only 8 to 10% of earth crust is composed of non-silicate minerals. In case of silicate minerals, there are some few examples, that is feldspar and the quartz. Feldspar contains around 51% of the silica, whereas quartz consists of 12% of silica. In case of non-silicate minerals, which do not contain silica, any mineral which do not contain silica is a non-silicate mineral. There are some examples, that is gypsum, dolomite, apatite, and it is of 8 to 10% of earth crust. Now we will discuss about the rocks. What are the rocks? Rocks is nothing but it's a hard mass. It's a hard mass. It can be composed of it's a hard mass. First of all, it's a hard mass. It can be composed of one or the many minerals. It can be consist of one mineral, or it can be composed of many minerals. So the petrology is a study of rocks. Petrology is study of rocks, and it is important term. We have to remember this petrology. It's not related to petrol or something. It's related to rocks. So we will study the different types of rocks here. So the first one is igneous rocks. Igneous rocks. Igneous rocks are nothing but, for example, I'll draw one diagram here. It's an earth horizons. Outermost part is crust. Okay. Here is a mantle. Here is a core. Again in core there is inner core and the outer core. And the inner core is solid part. And outer core is liquid part. Again in mantle there are two parts. It is outer and the inner. So it is a crust. Mantle consists mainly of magma, right? When the magma comes to the surface, right? When the magma comes to the surface, it gets solidifies, it gets cools down and becomes solid. It cools down and becomes solid. That type of rock is called extrusive igneous rocks, because the magma is coming outside the on the surface of the soil. That's why it is coming out. That is extrusive igneous rocks. When the magma moves horizontally somewhere here, somewhere in the voids, somewhere below the earth's surface, that is intrusive igneous rocks. The simple thing is, when the magma comes on the surface and gets solids, it gets solidifies, that is extrusive, because the magma is coming on the surface. That's why it is extrusive. And the example is basalt. And one more is intrusive. When the magma moves horizontally below the surface, that is intrusive, and it gets solidifies there. That's why it is called intrusive. And the example is granite. That's why maybe because of that granites are costly, because we have to dig them out. That's why the granites are costly. So this it is one type of rock, that is igneous rocks. The magma becomes it cools down and becomes solid. That's what the igneous rocks. The next one is sedimentary rocks. It is formed by the deposition and the cementation. It is formed by the deposition and the cementation. It can be igneous. For example, there is so the sedimentary rocks is formed by the deposition and the cementation. We'll see one of the flow chart here. See, the first thing is magma, that is come from the mantle. When it becomes when it cools down and becomes solid, it it is known as igneous rocks. When the igneous rocks weathers, whether weathers means weathering is like disintegration of rock, or it is decomposition of rock. When the igneous rock get weathers, it becomes sedimentary rock. That's what the sedimentary rock is. When the igneous rock gets weathered and after some period of time it gets cemented, it forms a sedimentary rock. When these igneous and the sedimentary rock come under the influence of temperature and the pressure, it forms metamorphic rock. This is what the process. You remember this flow chart. So the sedimentary rock is formed by the deposition and the cementation. There are some examples, that is limestone, sandstone, dolomite and the shale, and it is also called as secondary rock because it formed from the igneous rocks or the metamorphic rock. Once these rocks gets weathered, or and these weathered materials move from one place to other place. After moving, they'll settle somewhere. After some period of time they get cemented. So after some period of time, these rocks become sedimentary rocks. The third thing is, and the third type of rock is metamorphic rock. It can be, and when there is a rock, it can be igneous rocks or the sedimentary rock come under the influence of high pressure and the temperature, that becomes metamorphic rock. There are some examples here. See, the granite is igneous rocks. If there is a high temperature and the pressure, it becomes igneous. See, the sandstone is sedimentary rock. It becomes quartzite. Limestone is a sedimentary rock. It becomes marble. Shale is a sedimentary rock. It becomes slate. Basalt is a igneous rock. It becomes schist. You remember these examples. These are very important, and these can be asked directly in the exam. So let us we'll see the types of rocks based on the content of the silica. In case of acid rocks, the silica content is more than 65%. For example, granite. Granite contains more than 65% of silica. Okay, and it is called acid rock. And these rocks are also called as felsic rocks. In case of intermediate rocks, the silica content is around 56 to 65%. Examples are diorite and the selenite, syenite. In case of basic rocks, the silica content is low, That's why they are basic. The examples are basalt and the gabbro. And these rocks are also called as mafic. I hope you understood these rocks, different types of rocks. Now we will see the another topic, that is weathering. Weathering is nothing but it's a disintegration or the decomposition of the rocks. Disintegration as well as decomposition. And the weathering and the erosion are two different topic, two different terms. We'll see the difference. Weathering is nothing but it's a disintegration, whereas the erosion is nothing but it's a movement of that is disintegrated material from one place to another place. That's what the erosion is. That's a common difference, that is weathering and the erosion. There are weathering can be physical, weathering can be physical, weathering can be chemical, weathering can be biological. These factors influence the weathering. Physical is nothing but it's an impact. If there is a material, it is impacting. There is some mechanical effect, there is some force on it. It can be in terms of heat, it can be water, it can be wind, it can be snow, it can be a glacier. So it can be physical weathering, it can be chemical weathering. Chemical weathering is nothing but, see, the soil, air, water consist of many chemicals, right? For example, in case of chemical weathering, the carbon dioxide which is present in air or soil, when it combines with water, it forms carbonic acid. Carbonic acid, that is H2CO3. It forms an acid. When the carbon dioxide from the air and the soil combines with water, it forms a carbonic acid. This acid weathers some of the rocks like limestone, and it is very easily weathered material. This limestone is very easily weathered material. So this is one of the and this process is also known as carbonation. When this carbonic acid is weathering the material, means in this process is known as carbonation. Okay, the another thing is biological weathering. Biological means plant and animal. In case of plant, there are some mosses, lichens, those impact weathering of rocks. And the animals such as rodents, termites, ants, etc. See, this is the basic definition. Weathering is a breaking down or disintegration. It can be breaking down, it can be disintegration, or it can be decomposition of substances by physical, chemical, or biological processes. In case of erosion is nothing but movement of sediments from one location to another location. One location to another location. That's what the erosion is. This is what the basic difference between weathering and the erosion. Now we will see some of the important factors that is affecting the weathering process. The first factor is climate. There are five major factors. The first one is climate. Second is topography, time, plants and animals, and the parent materials. These are the five important factors that impact weathering process. See, here there are some active factors and the passive factors. In case of active factors, one is climate. It is active because it changes rapidly for a period of time. The second one is plants and animals. These two are active factors and rest are the passive factors. In case of climate, when we take climate, there are two important components of climate. Two important components which impact the soil weathering is, one is temperature, another is rainfall. If there is a high temperature, there is a high weathering. If there is a high temperature, there is a high weathering. In case of rainfall, in case of rainfall, if there is a high precipitation, precipitation is nothing but rainfall. The, this precipitation allows, you know, water to get into a cracks. This is, for example, this is a rock, it is a crack. If there is more rainfall, if there is a rainfall, this water gets into the crack. Once the surrounding becomes very cool, this water get freeze. Once the water get freeze, it expands. This expansion of water moves these rocks. This widens up the cracks. So this is how peeling and flaking takes off. Peeling and flaking, flaking of rock. Because of this, peeling and flaking of rock takes place. And this process is, we can also say this is freezing and thawing. Because once water gets freeze, it widens up the cracks. When it becomes thaw, it when it evaporates, it becomes, again it loses the strength. That's how it is. And the second factor is topography. Second factor is topography. See, there is a hill, if there is a if there is a steep slope, if there is a steep slope, the gravity will be, pulling all the materials. See, somewhere here is a rock. The gravity pulls the material here. So if there is a steep slope, there is a high case of high weathering. And one more case is, for example, it is an hill. Here is a rock. Consider it's a rock. So it come under the influence of high temperature and direct wind blowing towards it. When there is a high temperature, there is a high weathering. When the rock getting under the influence of high speed wind, it weathers fast. So this is how the topography, influence the weathering process. The third one is time. If there is a more time, more weathering. And the fourth one is plant and animal. Plants like lichens and mosses influence the weathering process. Animals like, rodents, ants, termites. This helps in the process of weathering. And the fourth and the last factor is parent material. See, see, different rocks having different rate of weathering, right? For example, sedimentary rocks are more resistant to weathering than compared to igneous and metamorphic rocks. Sedimentary rocks are more resistant to weathering when compared to igneous and metamorphic rocks. So it depends on the parent material also. Not every rock and minerals are equally resistant and equally susceptible to weathering process. So this was the last factor influencing the weathering process. Now we will, we'll see some of the questions which have been asked previously in many exams. Some of the basic questions. We'll see them. Okay, let's see the first question which have been asked in AAO exam 2021. The question is, which one is not a sedimentary rock? Granite. Granite is not a sedimentary rock because it is a igneous rock. Rest are the sedimentary rocks. The second question is, which among the following is a rock mineral of boron? We have already discussed. We have already known some of the minerals and their sources. So the boron mineral comes from tourmaline. Pyrolusite is a mineral of manganese. Apatite is a source of phosphorus. Orthoclase is a feldspar mineral. And the olivine is molybdenum. And the third question is, which of the following is an example of igneous rocks? Again, the same question. Granite is igneous rock, whereas the rest limestone, sandstone, dolomite are the sedimentary rocks. The fourth question is, the inherent capacity of the soil to supply nutrients to plants in an adequate amount is called. When it comes to inherent capacity, it's the soil fertility. It's a capacity of the soil to provide the nutrition, adequate nutrition in the right proportion to the crop. That's what the soil fertility. See, the pedology we have already seen. Study of soil, it's a Greek term. Edapology is the study of soil in relation to the higher plants. That's what the edapology is. The soil productivity is the ability of the soil to produce crop under a specific management system. When it comes to the capacity of the soil to provide the nutrition, it is a soil fertility. When it comes to productivity, it's an ability of the soil to produce crops under specific management system. Because soil productivity is a result of many factors, both within and outside the soil. When it comes to only nutrition, it's a fertility. When it comes to many factors, it's an soil productivity. So I hope you understood all the important concept. We will study some of the important important topics from the soil science in future classes. Thank you. See you again in the next class.